Okay, this is a kinematics lesson for acceleration. Okay, so we're going to explain what does acceleration means in kinematics. So these are learning objectives. Okay, I wouldn't. You can pause and just have a look. So before we go on, we need to maybe understand certain ideas. First, velocity is a vector quantity, and vector quantity has both magnitude and direction. Assuming that going towards right as positive, it means that having a plus 5 meters per second means that the object is traveling right and have a speed of 5 meters per second. So if you have a negative 7 meters per second, means that the object is traveling left, okay, at a speed of 7 meters per second. It's because going right is considered to be positive. Okay, so negative means that it is going left. If we do a comparison between plus 5 meters and minus 7 meters per second, the object traveling at 7 meters per second is actually traveling faster. The negative sign just only tells you that it is traveling towards left. Okay, so negative 7 meters per second is telling you this is where it is going, this is how fast. Okay, so we need that. Acceleration. This definition of acceleration is defined as the rate of change of velocity. It is also a vector quantity, so it have both magnitude and direction. The unit is in meters per second square. It can be calculated using change in velocity divided by the time taken, or another way is to take the final velocity minus the initial velocity, the starting velocity, divided by the time taken. Okay, so and other things is uniform acceleration means that the rate of the change remains the same during the time taken. So using a simple example, generally we'll be only dealing with uniform acceleration for this lesson. If an object has a starting velocity of 3 meters per second and 5 seconds later the velocity is changed to 30 meters, so it becomes faster. So what's its acceleration during this period of time? Okay, so in terms of calculation, acceleration is equal to the change in velocity divided by time taken. So you just take the final velocity, which is 13, minus away initial velocity, which is 3, then over the time span, which is 5 seconds. So it's just calculated to be 2 meters per second square. Point to take note that acceleration doesn't mean that it must be going faster. As long as there's a change in velocity, it counted as there's acceleration. So it can be going slow, it can be slowing down. So if you have a slowing down example, then the starting velocity is 15, and 5 seconds later it slows down to a stop, which means it's 0, not moving, 0 meters per second. So what's acceleration during this period of time? The formula is exactly the same. You just take the final minus initial. So final in this case is 0. Initial is 15. Okay, so 0 minus 15 is negative 15 divided by 5. So you get negative 3. Okay, so this negative, as mentioned before, acceleration is a vector quantity. It has direction and magnitude. Okay, the negative means the direction. One thing to take note: acceleration does not actually tell you how fast or how slow the object is moving. It tells you how fast is the object changing its velocity or its speed. So if the value is high, that means that it's changing its velocity rapidly. Likewise, if it has a low value, it means that it changes velocity slowly. What do I mean by that? I'll use the following table to help you to understand. Okay, so if let's say the object A and B has the same starting velocity of 1 meter per second, so they have the same speed. Okay, but A has an acceleration of 2 and B has an acceleration of 5. So if we do something after a certain time, you find that their final velocity is different. Okay, so if we look at A, okay, so you find that A and B is supposed to start 1, but after 1 second you find that A is 3, B is 6. A is 2 seconds later, A is 5, B is 11, 7, 16, 9, and so on. Okay, if you look at this, actually the pattern is actually very simple. It means that A has an acceleration of 2, so for every 1 second it changes its speed by 2. changes speed by 2, changes speed by 2, and so on. And of course for B, it has a higher acceleration, it changes speed by 5, by 5, by 5, and so on. So you see that at the end of 5 seconds, A has a lower speed as compared to B, okay, or velocity as compared to B. So even though they have the same starting velocity, so acceleration changes the speed of the object, okay, at different rates. So the larger acceleration, the greater the change is velocity. Okay, the greater the change in velocity. Okay, I highlight the change in velocity, not the greater the velocity. Okay, so one way is to think in terms of two-person riding bicycles. A is actually a normal person, B is an athlete. So even though they may have the same starting speed, but B is stronger and can change its speed faster than a normal person. So in the end of the 5 seconds, actually the athlete can ride at much faster speed due to his higher acceleration. Okay. So other common pitfall is that do take note that having fast doesn't mean that it must have a high acceleration, or slow doesn't necessarily means that it must have a low acceleration. A actually, for example, actually a normal person can have a high starting speed, okay, as compared to B, or B can has a low starting speed but can have high acceleration. So it actually means that the starting velocity does not influence the value of acceleration. Instead, it is the person itself that actually influences. So in the example of rider, the B athlete that has the ability to ride high acceleration, whether he is starting slow or starting fast, his acceleration don't depend on whether he's slow or fast. Okay, having a slow or fast velocity. Okay, so then what does zero acceleration means? Okay, zero acceleration means that there is no change. Since if you have some value, you'll change. Zero means that it's plus 0, plus 0, plus 0. Okay, so that means that there's no change. It means that velocity remains the same, okay, or stays constant. Okay, so very simple is that a runner who is running at 5 meters per second is not, is not speeding up or slowing down, has an acceleration of 0. Okay, so one common misconception students may have is that having 0 acceleration must mean that the velocity is also at 0 meter per second. Or the other way is that if somebody is not moving at that point in time, must mean that acceleration must be 0, which this is easy to understand, but this one may be a bit more difficult. If you see an object not moving, their acceleration seems to be 0, but that may not be true, because an object can be temporarily at that point in time not moving, but it is actually ready to move once you give the go timing. Okay, understand? So as mentioned before, acceleration is a vector quantity, so it has both magnitude and direction. As we have seen before, acceleration can be negative. So example, okay, if A and B has starting velocity of 30 meters per second, A has acceleration -2, B has acceleration -5. So what does it mean? Okay, the table will show. So it's actually also quite simple. Okay, it's a change in velocity. So originally they start from 30. So since this is -2, 28 -2, 26 -2, -2, and so on. Okay, then in this case this is -5, -5, -5, and so on. Eventually you find that having a -2, the end velocity is 20. Having a -5, the end velocity is 5 meters per second. So having a higher negative acceleration will actually change your velocity more. So another way to think of it, if you're riding a bicycle at high speed, if you press the brake lightly, your acceleration magnitude is less, like in this case -2. Your velocity change by a little. But if you press your brake hard, your acceleration is more, magnitude is more, so you slow down very quickly from 30 to 0, and so on. Yes. Okay. In all the previous situation, it's noted that all the objects are all slowing down. Okay, whenever you have negative acceleration. But right now I want to caution you that a negative acceleration actually does not necessarily mean that it is slowing down. Okay, does not. In fact, actually it can mean that the object is speeding up under certain circumstances or situation. So what is this type of situation? If, let's say right now, is that object A has a starting velocity of -2. Okay, instead of a positive starting velocity, it has a negative starting velocity and acceleration. If you apply the same method at different timing, so if your velocity starts at -2, if you subtract 1, you'll be -3, subtract 1, -4, subtract 1, -5, subtract 1, and so on, and eventually at 5 seconds later, you'll be at -7. So again, if you compare -2 starting, -7 at the end, do you realize that actually you are going faster? Okay, you are going faster because -7 meter per second is actually faster than -2. Okay, if you recall our revision, the negative only just tell you that you are traveling in a certain direction. In this case, maybe left. So remember that negative sign in velocities only means the direction of traveling object. So if you do a comparison, this object actually became faster. Okay, and you have negative acceleration. So negative acceleration doesn't necessarily mean that the object must slow down. Okay, negative acceleration just only always subtract, bring the number down by negative certain negative amount. Okay, so actually if you observe the pattern, depends on the velocity of the object. If the object is positive velocity, then of course positive, you subtract, the number becomes smaller. Okay, but if your starting velocity is actually negative, okay, and you subtract, you become a negative larger number, so it becomes speeding up. So which actually means that since negative acceleration does not guarantee that you speed up, doesn't guarantee that you slow down, positive acceleration actually doesn't guarantee that you speed up. Okay, so which means that when which situation is the positive acceleration actually doesn't cause you to speed up is that if your starting velocity is actually negative and your acceleration is a positive, it will cause the object to slow down. As given example, if your starting velocity is actually -5 and your acceleration is actually +1, so if you +1, +1, +1, +1, actually this pattern is that your object is actually slowing down from traveling -5 to when to stop. Okay, so one way to remember is using analogy in math. You know that if you have two numbers, one positive multiplied by positive, you get a positive, or one negative multiplied by positive, you get negative, or negative multiplied by negative, you get positive. Okay, so if you use this as an analogy, if you associate first number as velocity, second number as acceleration, if your result is positive, it means that it speeds up. If your result is negative, it means that it slows down. Okay, so or another way to remember is that as long as velocity and acceleration have a different sign from each other, it means the object must slow down. Okay, which means that if velocity and acceleration have the same sign, they actually will speed up. Okay. Okay, right now we come to this called special section of acceleration of free fall. Free fall means that it is the motion under influence of gravity. If you throw an object up, you'll notice that if the object rises up, you will actually slow down its speed. But after it rises to the top, as it falls down, it will actually start to speed up. So if an object going up, you will slow down, and then after it reaches the top, it goes down, you will speed up. Okay, so this one is what you should observe. In both our motion, there is a change in velocity, so slow, speed up, right? Okay, so both part of motion, there's an acceleration, and this acceleration is known as acceleration of the free fall. The value of this acceleration near the surface of the Earth is about 9.81 meters per second square. Sometimes usually we round it up to 10, okay, for simplicity's sake. And the symbol we use is, instead of using A, we use G. G equals to 10. Okay. So this acceleration of free fall, since they're speeding up and slowing down, so what's the sign of the acceleration of free fall? It really depends on which direction you treat as positive. Generally, we treat going up. If we treat going up as positive, then acceleration of free fall is known to be having a negative value. So acceleration of free fall, okay, I'll use the actual numbers to help you to understand why is it that it is negative. Okay, so but let's just assume it's negative. Assume you launch an object that's 100 meters per second, and then the acceleration is negative 10. Okay, so the following table would describe the velocity of the object at different timings due to g, okay, which is negative 10. Then remember that when the object is going up, it would slow down. So see if the table values fits, okay, the motion. You find that at 0 seconds, 100. Then 1 second later, remember under g means that it is subtract away 10, so it becomes 90. From 100 become 90, 80, 70, 60, and so on and so forth until it reaches that time equal to 10 seconds, it would be 0. So it actually describes the speed of the object as it goes up, and then over here at the top, velocity is 0. Okay, this is what it meant. Okay, so after the object reaches the top, okay, which is velocity starting at 0, okay, then the object will start to fall down and down. So it means that if it moving down, if we going up as positive, so when the object goes down means that the velocity must be negative. Okay, so there's actually no need to change the sign of acceleration. It still will continue as g to be negative 10. And we will actually see what will happen. The table will show that the next table will show that the fall will be going faster and faster due to g. Okay, the negative velocity is just show that it is traveling down, and the magnitude will become bigger and bigger as it goes by. Okay, so you start from 0, and then you still subtract away 10. Okay, remember it was 100. It was from 100. Then after that it becomes 0. Then from 0 subtract 10 again, become negative 10. Subtract 10 again, become negative 20, and so on and so forth until it reaches at 20 seconds, it becomes fast. You realize that again, negative just tells you that it is going down. The value 10 tells you how fast. So 10, 20, 30 is actually becoming faster and faster. So it actually describes the entire motion of going up. The velocity is 0, and then as it falls down, over here the velocity becomes negative 100, which is faster and faster, and g will still be at negative 10. Okay, be it going up or be it going down.